Good morning, everybody. This is Mr. Allen here. We are going to look at section 1.2, points, lines, and planes. So let's get started. A point has no dimensions. It's just a location on a plane, and you're going to represent it by a little tiny dot. And a point is basically the smallest building block that you're going to see in geometry. So every shape that we make is going to be basically made out of a bunch of little points. And typically, we're going to name these with a capital letter. So if you look down here, you'd call this point R, although normally you wouldn't actually write the word point. You would just write it with a little r. A capital R, but you can write it as point R. So you write it, or just like that. Now, this is actually something that you've seen before, so I'm going to switch over to a graph. And you'll notice that this point right here, -2, 4, this is something that you've learned how to graph in algebra before. So a point, it's basically just a location that's somewhere. So this point is representing the location -2, 4. All right, so let's go back to the video and we'll keep going. Okay, so scrolling down a little bit, we'll go on to a line. So a line, it's one-dimensional. And a line is basically an infinite set of points. And it's written like this, as this green line here. And these little arrowheads at the top show you that it's going to extend without end. The arrow means that it just keeps going. And even though every line contains infinite points, typically we think of a line as being drawn between any 2 points. And because of that, you use 2 points to name a line. And if there are multiple points that are labeled on a line, then you can choose which ones to use. So let's go ahead here. They're usually going to use 2 letters, but occasionally we have this little lowercase letter that is going to represent a line here. So it's good to know that there are 2 ways that you'll see it. You might see it as this little line B, or you might see it as a combination of 2 of the points that are physically lying on the line. So for example, we could use EF, or maybe we could use DE. And we also want to make sure that we label them with these little symbols at the top. See, this symbol shows us that there's a line here. Notice how we're drawing little arrows here to make sure that we are representing the fact that this line is going out forever and ever and ever. Okay. And yeah, you can also write line right here for line B. Moving on, collinear. So 2 collinear points basically means that they lie on the same line. So 2 points on the same line. Co is a prefix that you've heard before. Yeah, 2 or more points. Co is a prefix that you've heard before. It generally means both or together or with. So, for example, when you have co-workers or co-teachers, those are people who are working together or teaching together. So if you look at this line up here, D, G, and E would be 3 points that are collinear, D, G, E, and F, 4 points that are collinear. And you'll notice that it wouldn't really make sense to write just D and G because any 2 points can be collinear, even if a line isn't physically drawn on the page for them. Now, moving on to non-collinear, those would be points that are not on the same line. So, for example, we have G, E, F, and then H. Here is this little outlier that's not going to be part of the same line as the other 3. Okay. All right, so we are moving on to planes. So a plane has 2 dimensions that are extending without end in every direction. And you often see it represented by a parallelogram here. Okay. And so you'll typically see that it's named with either 3 or 4 letters, just because that's how many you'll need in order to differentiate it from a line. So for example, we can name this one using our capital letter here, just like we did with the line before. Or we could name it using 3 or 4 of the points that are lying along the same plane. So for example, we could say X, V, and Y. Or we could try, let's see, X, V, Z, and W. Notice you can't use just X, V, and Z because those are all on the same line. You have to use 3 or 4 points that are not on the same line. See, 3 non-collinear points to find a plane. All right, moving on to the back. Coplanar, it's pretty much like collinear, what you would expect. So coplanar points are points that are on the same plane. So for example, there are a number of coplanar points that we can use here. So we'll just use the one at the top. So let's try T, W, P, and Q. So see how it makes a little rectangle along the top here? Those would be coplanar points. And points that do not lie in the same plane would be non-coplanar points. Easy? I think so. All right, so an example of some non-coplanar points would be, let's try and do T, Q, P, and then X down here. See, T, Q, and P are all along the top of the box right here, and then X is down here on the bottom left. So, doesn't quite work. Now, an intersection is basically where 2 things touch. So 2 lines intersect at a point, and 2 planes intersect at a line. As you can see here. Again, this concept is something you should have learned about in Algebra 1, how to find the intersection of 2 lines. But intersection of 2 planes is a little bit slightly different. And it can be a little hard to visualize, but if we draw in this plane at the bottom here, and then we draw in this plane on the right, hopefully you can kind of see where they intersect is in between this, is right along here. Yeah, I think that's point, is that RN? I believe so. Now let's move on to line segment. So a line segment is very close to a line. It's just not infinite. So a line segment is 2 endpoints and then all the points in between them. So A and B, A and B, and then all these infinite points in between. And we label it in a very similar way to the way that we label a line. The only difference, no arrows. Instead of arrows, we have endpoints. And so we don't draw the arrows. This is very important to remember how to label this because you don't want to accidentally label the hypothetical line AB when you're really only talking about a segment. Now moving on to array. Array has one endpoint and extends without end in one direction. So it's sort of like a hybrid line and line segment. Now, naming array is very similar to the way that we label a line or a line segment, but there's one catch. It's very important that you always start with the endpoint of the array. So, for example, we could do BC or BM and BG. Those are all the same arrays, but you want to make sure that you're always starting with B because that's where the endpoint is. Your endpoint starts above, or the endpoint of your symbol starts above, then it goes to the right here. Now, very frequently you'll come across opposite arrays, which are arrays obviously that go in opposite directions. More specifically, they're arrays that go in opposite directions but start at the same place. So, for example, FD and DF go in opposite directions, but we wouldn't really count them as opposite arrays. Instead, we could try EF going in one direction to the top right, and the opposite array would be going down this way. We'd say ED and EF are opposite arrays. Don't forget that we're starting with the endpoint each time. And if they're opposite arrays, the endpoints should be the same. EF and ED. Okay, so that's all you need to know for this video. Hope that was helpful, but ask me with any questions you have in class. Take care.